All right, 2017 AP Calculus AB number 2, infamous banana problem. When a grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by, I've already written some stuff here, this is the removal rate. That is good to know. This is going to be the removal rate. All right, let's keep reading. Where F of t is measured in pounds per hour, you can see where this is going as I scroll my paper down. And t is the number of hours after the store opened. Let's look back up here though. Notice that the removal rate applies for times from 0 to 12. This is the first 12 hours after the store opened. All right, after the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by this. This is the replacement rate. They're going to put bananas out there at this rate. And this is going to be in pounds per hour as well. Notice it's from 3 to 12 hours. So G of t is measured in pounds per hour. T is the number of hours after the store opened. Let's do number 1. Number 2. Part A. Let's do part A, I should say. We've already done number 1. How many pounds of bananas are removed? Okay, if I want to know the quantity, I'll take the integral of a rate. And this is a rate. And I want to know the removal rate accumulated from 0 to 2. So here we go, ft dt. So I have already typed these functions in my calculator. So take a moment and do that if you need to. Everything on mine is already typed in. I'm using x instead of t, and we're going to figure out what this is. So here we go. Math 9 from 0 to 2. And then f is the y1 function on mine. And with respect to x, or t on paper. And I end up with 20.051. Let's write that down. 20.051. And I also want to indicate the units. They didn't say to, but I think it's worth it. But they did kind of give it away what it is. So it's 20.051 pounds. And because I have the free time and I want to explain it in context, I'm going to write a sentence. 20.051 pounds of bananas are removed for the time period from 0 to 2. There we go. The final answer really is just the setup here and the 20.051 pounds. That should be sufficient. Here we go, part B. Find f prime of 7 using correct units. Explain the meaning of f prime of 7. Okay, well, let's find f prime of 7, which if we do by hand involves product, chain. Just don't do it. Okay, let's figure this one out using the calculator. Math 8, not by hand. The derivative with respect to time, technically, but in the calculator it's x. It is the y1 function at 7. We're going to press enter and get a number. We'll write the number down, then we'll put some context to it. So here goes. Negative 8.120. Okay, this function right here, this function is pounds per hour. The derivative of that would be pounds per hour because we took the derivative with respect to time. So let's put this in context. When the store has been opened for 7 hours, or you could say at t equals 7, which is fine. Okay, this is the rate of change of the rate of change, right? Because this is the derivative of a rate. So I'm going to be really careful with the way I word this. The rate at which bananas are being removed is, okay, decreasing because it's negative, decreasing by, put the number, 8.120. Now, I don't want to say decreasing by a negative because I've already built the negative into the wording. Okay? 8.120 pounds per hour. I'm going to call it pounds per hour squared. The rate at which the bananas are being removed is decreasing by this rate right here. Okay, part C. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Number of pounds of bananas, is it increasing or decreasing at t equals 5? So here's what I need to do. I need to find out the rate at which bananas are being removed from the table at t equals 5, and the rate at which they're being replaced, and I'll see which one's more powerful, right? So here we go. I am going to put bananas on the table in the 5th hour using the g function, okay? The g function is the rate of replacement, and then we have removal of bananas, so let's subtract at the 5th hour, and we're going to subtract that. Now, when I do this calculation, I'm going to see, is this positive, is this negative? So let's just type it in. I'm not going to take the derivative of g and f. That is in the context of what we did here. This is just pure rate. This is the rate of the rate. It gets wordy. All right, y2 of 5, because that's the g function, minus y1 of 5. And we're going to get this negative number here, and we're going to write that down. So negative 2.263, and I'm happy with that, and you're happy with that, but I do want to realize that it is negative, which means bananas, the poundage of bananas is decreasing at this rate, at the time t equals 5. At t equals 5, the number, if I could spell it correctly, number of pounds of bananas, I forgot how to spell bananas. My word, I'm struggling here. What is it, B-A-N-A-N-A-S? Okay, good. Just got confirmation from Mr. Holmiller. Number of pounds of bananas is decreasing. And I want to give a reason for this. It's because g of 5 minus f of 5, which we've just calculated, is negative. All right, part D. Let's see what it says. How many pounds of bananas are on the display table at time t equals 8? This one should be pretty straightforward. So what we're going to do is figure out, or read, how many pounds of bananas we started with. 50. How do you know? They said so. And then we're going to say, well, how many bananas, pounds of bananas, I should say, were removed? Well, let's subtract away all the removal of bananas, which happens with the f function. And, oops, I'm using x instead of t. Probably not a huge deal, but just for consistency with the way it was set up, let's use t. So there we go. And that happens from 0 to 12. And there's a little catch to this next part, so let's be careful. I'm going to put some bananas back, and we might say, oh, from 0 to 12. No, not from 0 to 12. And the reason why not is because they didn't start putting bananas back on that display table until hour number 3. So from 3 to 12. 3 to 12, g of t, dt, and this should do it, really. It's going to be this straightforward. Let's type it in, see what we come up with. Good thing this is calculator active. 50 minus the integral from 0 to 12 of the y1 function plus the integral from 3 to 12 of the y2 function, and press enter, and you wait. And I got something different than I should have gotten. Do you know why? Because they said t equals 8. Good learning opportunity. Here we go. Read the problem carefully. He said to himself in a video, I'm not going to change this video. I'm going to keep it going because it's a really good opportunity for us to learn and make sure we are reading correctly. Please be careful, he said to himself again. There we go. This should do it. That's better. 23. That's what I got when I did it in my head. 3, 4, 7. And how many pounds bananas? This would be pounds. All right, let's grade our paper now that we did it correctly. Kind of cheating when you have the answer key beside you, right? In case your little mistake, so you don't lead others astray. Part A, we got a point for the integral and a point for the answer. So integral, 1 point, answer, 1 point, explanation, just for the context. All right, the value of part B is worth 1 point, got it. And then the meaning, and I worded mine very similar to the way they worded theirs, maybe almost word for word, very similar. When the store has been open for 7 hours, the rate is decreasing. So basically, again, it's the derivative of a rate, and then we had to put the units in there. So that one was very important. They didn't mention units, but that does provide the context. Pounds per hour, I worded mine like that, same thing. Okay, part C. We got a point for considering f of 5 and g of 5. It's in some context, and g of 5 minus f of 5 is, in my mind, the most logical way to do this because replacement minus the removal. And so there we go. And then we have an answer with the reason, and this answer is decreasing. And the reason is because g of 5 minus f of 5 is negative. And then part D, we have 2 points for the integrals. Let's go with like 1 point each. So we earned a point here. I did mine in a slightly different order. They did their removal at the end. And this one was worth a point as well. There it is. And then the answer is 23.347.